Hey everybody, so what I'm going to go through with you really quick here is just a little bit of a relationship between what's called macrocircuits and microcircuits. Now, the two words micro and macro, and you may want to write this down, macro means large and micro means tiny. And so when we're talking about macrocircuits, these are the circuits that we've learned about basically throughout the entire unit. So wiring in your home or the circuits that we built in class, those are all macro circuits. And they contain four basic subunits, as you all are aware. And so just looking at this picture here in your textbook on page 319, if you want to follow along, we've talked about how the house is wired, and we've got things like circuit breakers and power lines and transformers that power down electricity into your home so it's safe to use. And you've got an electrical meter that measures how much electricity your house is using. If we take a look at this page, which is page 320, you can see in figure 4.44 here up in the top left hand corner is a picture of what's a typical house wire that's used. And you can see in the picture that there is a wire that's coated with white insulation, rubber wiring, or rubber coating on the wire, and that's what's called the neutral wire. And this is a live wire in the wiring in your home. The black wire is also a live wire, and it's called the hot wire. Now, what I mean by a live wire is both the white and the black are wires that carry an electrical current. And if you were to take a voltmeter and measure the potential difference or voltage across those two wires, you would get 120 volts. Or in some cases, if it's for an appliance like in your kitchen, like your stove and oven, or different appliances that require more, it might be 220 or 240, but 120 is pretty standard for everything else. And so these wires are used to provide electricity to these appliances. Now you can see though that there's a third wire there, and in this picture it's a bare copper wire. It doesn't have a coating on it. In some cases it might have a green coating on it, and this is what's called the ground wire. And this is just the wire that, and we've talked about ground wires in the past, that just allows excess electrical current that's not needed or built up, that would build up in other places and provide an electrical shock to people who are using those appliances. Instead, it sends that electricity to the ground, into the earth, in a safe and non-hazardous way. And so these three wires are set up in an important setup here to provide electricity to appliances so that you can use them in your home, but also so that, for example, if you go to touch the metal door of your oven to open it and pull out your sheet of cookies, that you don't get a really huge shock and electric jolt from that, because as your stove and oven is plugged into the wall, that it would be kind of building up an electrostatic charge in it as well. So that's what that ground wire is for, is to send the electric current to safely to the ground. Now if you turn to page 322 in your textbook, this is a page that talks about, and I'll just summarize it here for you really quick, summarizes the difference between macro circuits, like circuits in your home and the ones that we were building in class, compared to what's called microcircuits. And microcircuits are found in any sort of digital electronic technology. So for example, your computers or your calculators or your phones, all of these have microcircuits in them. And they consist of the four basic subunits, as do all other electrical circuits that are out there. They have a supply of electrons, they've got loads in them, they've got conductors. The wires are really tiny and usually just like little strands of copper, traces of thin traces of copper, rather than actual thick wires of copper. And then they've also got switches. But here's the main difference between microcircuits and macrocircuits, and it's the switches. In a macro circuit, we just got these switches that turn on and off, and switches have those two modes, those two states. They can either be on or they can either be off. And it's the same thing in microcircuits as well. However, in microcircuits, there are tons of switches, and the switches have a special name, and they're called transistors. And these transistors, again, are switches, so they have two states, on or off. But this generates in, if you're familiar with computers and sending electrical signals in a particular way, they use these two states, on or off, as what's called a binary code. So if you've probably heard of this code of ones and zeros. 0 means that the switch is off, and 1 means that the switch is on. And you can have thousands of transistors in these microcircuits, which can relay signals in particular ways that can then be used to perform particular tasks. And so these transistors are really useful in these microcircuits because you can use the processor in the circuit to program which switches or which transistors in the microcircuits you want on and off so that you can do these functions. And that's what a lot of these functions of, for example, iOS, the operating system for Apple phones, or Android for Android phones. These are operating systems that are programmed to tell your phone to close or open certain switches so that as you perform these tasks that they can actually perform the task that you're asking it to perform. And so that's the main difference that you need to know between micro and macro circuits, is that microcircuits do contain the 4 basic subunits. That's a similarity between them. But the main difference is that microcircuits contain special switches that are called transistors that generate a binary code where particular tasks can then be used or sent for these digital electronic devices to perform specific tasks. And that's all I've got for you guys for this lesson. Hopefully you took a couple of notes of the really important things. I mentioned the things that I felt like were most important out of these places, and hope you're doing well.